Hi students, welcome to video class number 5, and we are again, the topic is modeling a physical system. This is the part 2, and I suggest that you should hear this in the order of the recording, in the order number. Don't mix it up. Okay, so video class 1, 2, 3, 4, and so on, it should go. And not only that, sometimes the topic may be the same. You must be careful in looking at the part number. So all you should do is you should hear it in order, otherwise you won't be understanding anything, because the current video will be depending more on the previous video. Okay, in the last class we have done this example 1, where you considered a very simple RC circuit and you obtained the mathematical model. Now what is the meaning of mathematical model? Getting the differential equation that's in the time domain, and you will be converting that into S domain by applying Laplace transform. So these are the mathematical model. From this mathematical model, or from the transformed mathematical model, you can very well easily obtain the transfer function. Now from this transformed equation you can develop the transformed circuit, just as this. So here we have seen that the resistance R remains the same, while capacitance, the impedance offered by capacitance, will be 1 by Cs. All these things I have explained in the previous video. Now later on, using this transformed equation, you know how to develop it into a block diagram, and we have seen that even though this is a very simple circuit, this can be considered as a closed loop system, that too an unity feedback system. Okay, so in this problem, what you are expected is, from your side you are expected to at least, you should know how to derive the transfer function as I explained here. Okay, now the developing of the block diagram, I have included just to give you an idea about the block diagram representation of an electrical system. So this also you should know, because 95% of chance is there to ask you about the transfer function, deriving the transfer function of the electrical system. And it's not common to see that you are asked to obtain the block diagram, but if it is asked, you cannot say that that's out of syllabus. So you need to know how to obtain the block diagram. Now we are going to do another example. This is a bit more complex circuit in comparison to the simple circuit. That means you have a two RC circuit, right? R1 C1 in shunt with R2 C2. Okay, you have been given with Vi of t and V0 of t. Okay, now in this, the first thing is, in order to obtain the mathematical model, you need to apply KVL, and we know KVL is, you need to apply KVL, and this is actually your, I forgot to write, this is V3 of t. Okay, this node voltage is V3 of t. So you have an input Vi of t, and that's given to this R1 C1. So you can, then you have another mesh. Now at the output is taken across the capacitor C2. Okay, now in order to start with mesh analysis, so looking at the mesh 1, you are assuming a current I1, right? And in the second mesh you assume a current I2, right? So when you look at mesh 1, you can write the mesh equation as Vi of t, small vi of t, is equal to I1 R1 plus 1 by C1 into integral I1 dt, right? Minus, again, when you write the equation for this mesh, there is a current flowing through due to I2, which is in opposition to I1. So you will put in a minus, that will be 1 by C1 integral I2 dt, right? So this is the first equation, and you are calling that as equation 1. Now in the second mesh, when you consider the second mesh, the EMF is equal to 0, so this side is 0, 0 is equal to, now what is the drop due to I1? The I1 will be opposing to the drop due to I2, because we are writing equation with respect to I2. So with comparing to I2, I1 is opposite, so the drop will be, the drop due across the capacitor is due to both the currents I1 and I2. But since you are writing equation for I2, I2 is the main current. In with respect to this I2, I1 is in opposition. Look, I2 goes in this direction, I1 goes in this direction through the capacitor. So that this becomes minus 1 by C1 integral I1 dt, right? Then what about I2? Now I2 flows through this, so this will be I2 into 1 by C1 integral I2 dt plus R2 into I2 plus 1 by C2 integral I2 dt, right? Okay, now this is your second equation. Okay, now listen please. So these are time domain equation. Okay, so hope you understood why I called it as time domain, because all these functions are in time. This is I1 of t, I didn't mention that. This is actually I1 of t and I2 of t. So you can just write, when you write the notes, you may just write this as I1 of t and replace this as I1 of t, I2 of t. So it is obvious that these are all functions of time. Okay, now coming to the next part, that is, you are to transform, you are to write equation in the frequency domain. So what you need to do is, you need to apply Laplace transform to 1 and 2, right? Applying Laplace transform to 1 and 2, you will get this v1 of t will be written as capital V1 of s is equal to I1 of s into R1 plus, what about this, 1 by cs into I1 of s, okay, minus 1 by, this is 1 by c1s, c1, this will be 1 by c1s into I2 of s. Okay, so this can be written as R1 plus 1 by c1s into I1 of s minus 1 by c1 s into I2 of s. So let us call this as equation 3. Now coming to the second equation, when you transform the second equation, 0 is equal to minus 1 by c1 s into, look at this equation, this will be 1 by c1 s into I1 of s plus 1 by c1 into I2 of s plus R2 into I2 of s plus 1 by C2 s into I2 of s. So that you can write, separate this I1 of s as, so you will get this as I1 of s is equal to minus 1 by C1s plus I2 of s into what? I2 of s into 1 by, this is I2 of s into 1 by C1s, right? 1 by C1s plus R2 plus 1 by C2s, right? So call this as equation 4. Now look at this third and fourth equation, this and equation are called as the frequency domain equation. These are the frequency domain equation. Okay, now using this difference of equation, you can develop a transformed circuit, the circuit in S domain. So this is a circuit in time domain. Now the next step is to develop the develop a frequency, develop a circuit in frequency domain. Okay, now how to develop that So you can make use of these two expression, that is the third and the fourth. Let's look at the third equation. Now the first part, the third equation says that this is v1 of s. So that must be what? That must be an input, right? So let us call this as v1 of s. Then this equation says that the I1 of s, there is a current flowing through this I1. Okay, I will use that. So there is a current flowing through this, and let us call this as I1 of s. And the current moves on to R1, right? So you have an R1. Okay, so this is, let us call this as R1. Then coming to the second part, you can see that there are two currents, that is I1 of s and I2 of s. So let us finish this. Anyway, the current is flowing through R1. The same current is also flowing through the C1. So you can represent that as, see the voltage is equated to I1 of s into, the voltage is equated to I1 of s into 1 by C1s, meaning this 1 by C1s is the reactance offered by the capacitor. So you can represent that by a capacitor, and you can write this as 1 by C1s. Okay, now as you can see, that is not complete, because this V1 of s is not only 1 by C1s into I of s, that gets subtracted by the another term called as 1 by C1s into I2 of s. What is the meaning of this? So another current which flows, so this is the current I1 of s, so this must be your I1 of s. So another current is flowing through C1 of s in opposition to I1 of s, that is your I2 of s. So that forms this, right? So this term gives you an idea that this particular circuit has got one more mesh. Now coming to the second equation, which is 0 is equal to, that means the second mesh is not going to have any voltage. So the second mesh is, okay, second mesh suggests that that's the equation for the, so then you can see that 0 is equal to I1 of s into minus C1 of s. So when you say, when you have a current, so you need to assume the current to be I2 of s, right? Now this I2 of s in opposition to I1 of s, so that's why this minus sign, I1 of s into minus I1s, so that becomes a part of this I2. Now I2 of s is I2 of s into 1 by C1s, plus you have two more, this thing, no? That is R2 plus 1 by C2s. So what must be that? That is nothing but it is, so this is R2, then next is the C2 will be replaced by 1 by SC2. Okay, hope you understood this. 1 by C2s, and the output we call as the V0 of s. Now there is one more node voltage which is marked in the question, that is V3 of t. So obviously this V3 of t will be V3 of s, right? This V3 of t will be equal to V3 of s. So what is this? This is actually the circuit in S domain. Okay, so this is the circuit in time domain. So it's very easy. I mean, after writing down, you don't have to draw this as I explained. You can just simply write these as, say, this is the, mark this as V1 of s. V1, here you have V1 of s. I1 of t will be replaced by I1 of s. Resistance will remain as such. Every capacitance will be what? 1 by C1s, right? Had it been inductance, it will be s into L. Say for example, if you have an inductance of value L, then that has to be replaced by s into L. Every capacitance has to be replaced by 1 by C1s. Now look at this. This R2 remains as H, as the same, but C2 changes to 1 by C2s in the S domain circuit. Okay, So this is actually the transformed circuit or circuit in S domain. Okay, so just you must have noticed this. That is, the key point is in a transformed, that is T domain to S domain. When you convert T domain to S domain, R remains as such in the S domain, while capacitance will be represented by 1 by Cs, while the inductance will be S into L, and all the functions, right, f of t, that is, it can be Vi of t, or it can be I1 of t, I2 of t, or V0 of t, or V3 of t, whatever is, that will be represented by capital F of S. Okay, so what you need to do is you don't have to, you don't have to draw this as I explain. No, these are the two equations upon which this is based on, or this diagram we actually draw it from these two equations. Okay, and if it's so lengthy and confusing, what you just need to do is just convert as this, okay, the time domain into its corresponding S domain, so that you are going to get the S domain circuit. You should not change any polarity or whatever is shown in this time domain. You should maintain that. The only thing is that capacitance and inductance value changes to its corresponding reactance in the S domain. Okay. Okay, our next aim is to obtain the transfer function. So the question in the here the question is obtain the mathematical model and the transfer function. So you are supposed to find out the transfer function. Now we know that the transfer function is nothing but it is V of S by Vi of S with the initial condition set to 0, right? So what is the logic behind this? In the previous problem also we obtain as many equations as we can, right, from this, and some way or other find out a relationship between Vi of S and V0 of S. So finally you should get an equation which only consists of Vi of S and V0 of S. So this is Vi of S, this is not V1, this is Vi of S. So this is the logic behind this. Okay, now in order to get the transfer function, or you are actually in search of a relationship which has only Vi of S and V0 of S, then we will be able to get the transfer function. But when look at the figure, now just by observing the figure you will not be able to get this a straight equation relating Vi of S and V0 of S, because even if you apply KVL or KCL, whatever you apply, you won't get a single expression relating Vi of S and V0 of S. But applying the same to different measures, that is KVL and KCL at the node, we will be able to get many equations, and by proper substitution and proper selection we will come to a equation which relates only Vi of S and V0 of S. Once if you get that, you can take the ratio of that from that, and the result will be the transfer function. Okay, now let us proceed. Okay, the first and the primary equation that you get is from the first mesh. When applying KVL, you will get an equation like this: V1 of S is equal to R times I1 of S plus V3 of S. So what is V3 of S? V3 of S is nothing but it is through the capacitor you have two current, I1 of S and I2 of S. We know that they are in opposition. This I2 of S in opposition to I1 of S. So I'm using I1 of S minus I2 of S into 1 by C1S. Okay, in the last class also I mentioned what is this 1 by C1S. It is not the value of capacitance, it is the reactance offered by the capacitance. So that reactance into the net current flowing through that capacitance will give you V3 of S. Okay. Okay, now our primary equation is this equation, because the required thing is the transfer function, which is the ratio V0 by Vi of S. So we have Vi of S. Now we will never leave this Vi of S. Now when you analyze this expression, this I1 of S is a
is a current at the input side. But now this, if there is a chance to represent this I1 of s into I2 of s, actually you are taking this equation to the output side, so that to within a short time you will be arriving at an expression relating vi of s and v0 of s. Okay, now is there any way to substitute I1 of s? Coming to this equation 2, you will be able to get what is I1 of s. Okay, now finding that I1 of s and substituting in v1 of s, we will get an expression. Okay, let us see what it is. Okay, now look at the second equation. So from the second equation, we will be able to find out what is this I1 of s. Using that equation, you will get this, you can bring this C1s to this side. So this is C1s into V3 of s plus bringing I2 of s to this side, you will get I2 of s. Now, this can be substituted in equation 1. That is, instead of I1 of s, so you will be getting this equation. Now look at this equation. Now you have a V1 of s, which is your input equation, input voltage. Okay, one of the requirement for the transfer function. And now you had an expression relating I1 of s, and now you have totally changed into an I2 of s. That means you have moved ahead towards the output side. Okay, now okay, now the next step is rearranging. Rearranging means you have V3 of s, here also you are having V3 of s. So you can have this V3 of s into R1 C1s plus 1. I mean, okay, so this is plus 1 plus you have an R1 I2 of s, right? Okay, now look at the circuit. Now we have, in this equation, we have V3 of s. Now we need to go ahead, right? So now if there is a chance of representing this V3 of s in terms of I2 of s, how will you do that? Now what can you say about this voltage? This is the voltage that is across the capacitor, or that is your V0 of s, right? Now these are two nodes, right? V3 of s and V0 of s. So how will you find the current flowing through this? Okay, this is V3 of s, this is V0 of s, and the current flowing through that will be the potential difference divided by the resistor. So you can write this I2 of s to be equal to what? I2 of s to be equal to, look at this, I2 of s is equal to V3 of s. Okay, this V3 of s minus V0 of s, V0 of s divided by that R2. Okay, now from this, so call this as equation 4. Now from 4 you will be able to get V3 of s, right? V3 of s. Now how to calculate that? So from this you will be able to get V3 of s to be equal to, bringing this, so this is I2 of s into R2, right, into R2 plus V0 of s. Okay, I2 of s into R2 plus V0 of s, that is your V3 of s. So call this as equation 5. Okay, now on substituting 5 in 6, you can get rid of this V3 of s, so that you can represent your V1 of s in terms of I2 of s. That means you have moved one again a step further, right, to I2 of s. That means you are approaching to this output. So again in 6, when you write the equation for that, you will be getting this as V1 of s is equal to, V3 of s is I2 of s into R2 plus V0 of s, right? I2 of s into R2 plus V0 of s into R1 C1. Look at this expression, R1 C1
s plus 1 plus r1 I2 of s. Okay. Okay, now rearranging this v1 of s, rearranging this v1 of s is equal to, you can take the I2 of s together, so that you will get this as I2 of s into, so what all terms that comes along with I2 of s? I2 of s is, okay, r2 into r1 c1 s. Okay, so this, that will be r1 r2 r2 c1 yes plus r2, right, plus r2, then plus r1, this one r1 plus v0 of s into r1 c1s plus 1, right? Okay, now look at this expression. So you have now one I2 of s and unknowns are v0 of s. Now let us see, can you have any method, or can you by any means, can you convert this I2 of s in terms of v0 of s? Look at that expression again. So this I2 of s is the current flowing through this capacitor, but across the capacitor you have a voltage V. And if this is the impedance, what will be the current flowing through this? This is V0 divided by that impedance. That means your I2 of s, your I2 of s is going to be equal to V0 of s divided by 1 by C2s, or you can bring this up so that this become C2s into V0 of s. Okay, now you can substitute this value in I2 of s. So substituting that, you will get this as C2s into V0 of s, right, into R1 R2 Z1 S plus R2 plus R1 plus V0 of S into R1 C1 S plus 1. Okay, now look at this expression. You have all V0, right? Okay, now you can take this common, so that V0 of S is common. So don't forget about this C2S. This C2S has to be multiplied along with each terms inside this bracket. So doing that, you are taking the whole of V0 of S. Doing that, you will be having R1, R2, C1, bringing the C2 here. So C2 into S square, this is S into S square, plus R2 C2S plus R1 C2S, right, plus, no sorry, plus you have R1 C1S plus 1, right? So this is actually your V0 of S, V0 of S, right? Now what you want is, actually what you want is V0 of S by VI of S. Now what will be that? So that is, you want to find out V0 of S by VI of S, right? That will be equal to, bringing this here, so this is VI of S, bringing this down, you will get this as the numerator. So this will be 1 by R1 R2 C1 C2 into S square plus R2 C2 plus R1 C2 C2 plus R1 C1 the whole into S plus 1. Okay, now what is this? This is actually your transfer function of this network. Okay, right? Hope you understood this. Now, okay, now the next step is how to get the block diagram of this. Now look at this, look at the starred relation. I've starred V1 of S
V3 of s, that is the voltage that comes in between V1 of s and V0 of s. Then you have another equation I2 of s, which also relates V3 of the second and the final voltage divided by R2, and you have the final this thing. So you require these four equations to draw the block diagram. Okay, starred four equations. One, that is V1 of s, V3 of s, I2 of s, and V0 of s. I have rewritten again here. Okay, now what I am planning to do is you start from this, from V0 of s to Vi of s. That's the logic of framing up block diagram. Okay, anyway, in any block diagram, the basic block diagram has to be like this, right? So inside this block you can have lot of things. So you will be having a Vi of s and a V0 of s. This is how it should look like. So inside the block you will have several blocks, and that's what we are going to find out. So we have two equations, that is V0 of s as well as Vi of s. Now the question is how to correlate it, and that's what we are going to do in this block diagram. So coming to the first, before that, anyway, it is necessary that you need a Vi of s and you need a V out of s, right? Now for the meantime, these are not related to each other as per this diagram. So these are two terminals at two ends. Now by using this equation we are going to relate this. Okay, so let us look at this first thing. It is said that V0 of s is 1 by C2s into I2 of s. That means you can represent this by a block diagram, right? So that is, the V0 of s is a result of what? Result of multiplying what? Multiplying a signal I2 of s. So you can think of like this. This is your I2 of s, and I2 of s when gets multiplied by 1 divided by C2s will give you V0 of s, right? That's what this equation says. V0 of s is equal to this thing into I2 of s. Yes, as per this diagram also, I2 of s gets multiplied to, so that V0 of s. Now coming to the second part. Here it gives you what is this I2 of s. I2 of s is actually what? Actually, when you look that, it is a difference in two voltages, that is V3 of s and the output. Okay, now if this should represent if one of the components of I2 of s is V0 of s, meaning that this has to be fed back, right? So that means you can have what? And not only that, there is so this can be rewritten as V3 of s minus V0 of s, the whole divided into R2, right? So this is actually, this I2 of s is to be multiplied by a block by 1 by R2, right? And what must be the input that is to be given? The input has to be the difference between this V3 of s and V0 of s. Now from where you will get V0 of s? Here is V0 of s. Now you need to assume that it has to be, the output has to be the output of a summer, where one input must be V3 of s, right? This has to be V3 of s. Then only, now the next one, you will get this from this side, right? But you should put a minus sign here. So what will be the output here? This will be V3 of s minus V0 of s. And if it requires to be I2 of s, that has to be multiplied by 1 by R2, right? So this is it. Now let's look at to V3 of s. Now how V3 of s is formed? V3 of s is actually the difference between I1 of s minus I2 of s. So again you require what? This V3 of s is actually multiplied by a term called as 1 by C1s. That means here you have one more block called as 1 by C1, yes, right? And what must come here? That must be I1 of s minus I2 of s. You will get I2 of s from here. And where is I1 of s? I1 of s is one of the input of this summer. So okay, no, okay, we'll just have a, so this must be your I2 of yes, right? And what about this? This has to be your, sorry, this is I1 of S, and this has to be your I2 of S, right? Now what does this equation says? I1 of S minus I2 of S, right? So that is, here you are supplying I1 of S, from here you are getting I2 of S, you are subtracting this. So in order to subtract, you should put a negative sign. Here it is positive, so this will be I1 of S minus I2 of S. So this, to represent V3 of S, it has to be multiplied by 1 by C1S. Now then comes the last one. What is this Vi of S? Now from this expression, from this you can find out what this I1 of S is. What is this I1 of S? I1 of S, now from this equation, I'll read now this equation, you can evaluate I1 of S. I1 of S is Vi of S minus V3 of S divided by R, right? Is it clear? So where is Vi of S? Vi of S is the terminal here. Vi of S, and now this is your V3 of S, right? From this V3 of S, you have one more adder where you will subtract this V3 of S, and this is your Vi of S, Vi of S minus V3 of S. That is this. Now in between this, here you have a block, and inside this block you have a gain of what? Gain of 1 by R1, right? So this is 1 by R1, right? So you must neatly draw this block diagram, and inside that block you should write like this. So this is actually the block diagram, and what I meant to say is, see, in the previous problem we had a very simple, we have proved that, say, look at this, you have only a simple RC network that has a closed loop that is represented by a simple closed loop feedback system. Now what about this? When you have one more RC network along with this, that actually that's a circuit, right? So the circuit is, you have a 2 RC network. When it becomes 2 RC network, the block diagram is getting complex, right? How many feedbacks? You have 3 different feedbacks. So what I want to say is, as the components increases, the block diagram gets more and more complex. Okay, now from this portion, what you need to study mandatorily is, you need to study how to find out the transfer function from a circuit, but developing the block diagram is not actually specified in your syllabus. Now even if someone asks you to develop a block diagram, you cannot claim that that's not in the syllabus, but that's about 95% is a chance of asking transfer function of a circuit. Okay, but we will be dealing with block diagram modeling. In block diagram modeling, you will not be asked to derive the block diagram, but your block diagram will be given, such complex block diagram will be given, and you will be asked to find out the ratio V0 of S by V of S. Okay, now that we will study in the next topic, that is block diagram detection technique, and there we will apply those techniques to find out the transfer function, and there we will take this example again, and we will be finding, by using such techniques, we will be finding the ratio V0 of S by Vi of S. So at that time you should get what? You should get the transfer function. You should get the transfer function just as we derived it directly from the circuit. Okay, that we will prove at that time. Okay.